wherever you are, good day. We're happy to start the second session today of our seminar. Unfortunately, we will not be able to start with the first scheduled presentation because there's been some illness, but we're happy that we can introduce Elena Grigorieva to do her presentation today as we open this session. And Elena will be presenting on bioclimate and human health in the Russian Arctic zone. Elena, the floor is yours.
First of all, before I start with my presentation, just a few words of introduction for today. We know that nowadays the ideas of sustainable development and improvement of the quality of life are the most recognized goals of social and economic development. And health is one of the most important indicators in integrated assessment of the population quality, serving as an integrator of systems, social and natural relations. The vast Arctic region with a low population varies significantly in the ability to provide adequately good quality of life due to a variety of natural and social surroundings. Human environments, both natural and social, are characterized by a large discreteness and spatial inhomogeneity. Climatic and weather conditions in the northern latitudes by themselves, reinforced by recent dramatic climate change with a high probability of temperature extremes, contribute to social and economic changes in urban and rural areas here. The study of these changes should address specific natural, medical, and social features, including concerns of indigenous people. Today, we know that climate is changing globally, and climate change in the Arctic carries wide-ranging implications for indigenous and non-indigenous inhabitants, causing direct and indirect effects. Yesterday, we had two panels, and almost in every presentation, we could hear the signs of climate change and how the people in the north areas address to these issues. Climate change is manifesting itself in increase of ambient temperature first, which may decrease the incidence of hypothermia and associated morbidity and mortality. And as an indirect effect, climate change can reduce access to traditional foods. Extreme weather events such as heat waves or cold spells can seriously change subsistence hunting and fishing of indigenous people. The emergence of new climate-sensitive disease and the damage to sanitation infrastructure can potentially increase food and waterborne infection disease. In the light of growing urbanization in the Arctic, the combined effect not only climate warming, but also urban heat islands in the northern cities should be considered with a high probability of occurrence and exacerbation of extreme temperature events. As the role of health grows in both disaster risk reduction and climate change adaptation paradigms, the need for linking these two approaches will increase, and this is especially crucial for the Arctic areas. The main purpose of our discussion today is to exchange research to enhance international scientific projects, to consolidate surveys on human health and social development in the Arctic countries, with an ultimate goal of improving the social and demographic security of Arctic residents in warming environments. Welcome all participants and look forward to a fruitful discussion of the second day of the Fulbright International Arctic Seminar. Thank you. So this just like an introduction, and now let me start with my presentation. Now I will demonstrate the screen. And can you see my presentation?
Yes.
And let's start. So today, as it was introduced, I will talk about bioclimate and human health in the Russian Arctic zone. Despite all global issues of climate change that we were talking about, natural disasters and epidemic that we have COVID pandemic today, now we will talk about the surrounding climatic environment and its thermal state. So now we will talk not just about these very dramatic issues, but about those environments, thermal environments that is surrounding our body. Human health and well-being depend on the complex influence of many factors, one of which is the thermal state of climate. The latter involves the interplay of great variety of atmospheric variables such as air temperature, humidity, wind, and solar radiation, as well as physiological and behavioral variables such as activity level, clothing, posture, and underlying physical conditions. Because of the complicated way these all come together, various unitary indices have been devised to assess these influences. The thermal load of the environment on the human body is an important indicator of climate discomfort, especially the extraordinary cold conditions of the Russian Arctic or of the all Arctic areas, with extremely low temperatures combined with a strong wind. The purpose of this study is twofold. First, we will identify and evaluate the bioclimatic conditions in the Arctic as natural drivers of the quality of life of the population. And second, we'll stop on the acclimatization issues of Arctic and residents that are traveling from Arctic and those people who are traveling to Arctic. So twofold study today. In order to show the interaction of climate and humans, objective bioclimatic conditions are related to the health status of the population based on statistical data of morbidity and mortality at the Russian Far East, with Chukotka as the north, and we will compare it with southern areas of the Russian Far East, first of all with Jewish Autonomous Region. To analyze the thermal stress on human body, a combination of bioclimatic thermal indices was calculated based on climate data. Normal equivalent effective temperature, one of these indices which combines the effect of real temperature with air humidity and wind speed. This slide shows the spatial dynamic of this index at the continental part of the Russian Far East in winter, which is more severe and really very severe season in the whole continent and in Arctic as well. We can find very low perceived temperatures at the far north, not only because of low real temperature, but due to high winds. And at this slide, we can see the differences between the perceived temperature expressed by normal equivalent effective temperature and real air temperature, which is really very high during the whole year, and especially in winter season, and in almost all areas in Kamchatka, in Sakhalin, and in Chukotka as well. These very high difference, especially in January. We took two seasons with the main months of this season, January and July, and for the whole year as well. One more index that we show here today is a respiratory heat exchange between the lungs and surrounding air. Index which depends on air temperature and humidity, as is adjusted for wind in wintertime. And we can see that it is really very high in the northern areas and all the year round, which can influence on respiratory health of the people living here. By the way, this slide shows the another index, ATSI, which I will discuss a bit later today. On the other hand, we can see now respiratory, we can see health status expressed by health statistics, morbidity and mortality of the population. On this slide, we can see morbidity, all cases, circulatory and respiratory disease, and huge differences, almost twice, between Jewish Autonomous Region in south and Chukotka at the north of the region. The same we can see for respiratory morbidity, looking at different age groups, where children and young people are most vulnerable with the highest indicators. So respiratory morbidity for children has really very high level, and Chukotka is almost twice higher than in any other area of the Russian Far East. And in compare with Russian for Russia as a whole. But we can find very different situation for mortality. Examples of all causes and circulatory disease mortality we can see here, which is much lower for Chukotka than for other regions at the Russian Far East. Why it is so? In the Arctic zone, the older generation practically doesn't take part in the formation of mortality. They migrate to the warmer regions when retired, and this is reflected in relatively low indicators of mortality in Chukotka and in other regions at the north. Next slide shows correlation coefficients between normal effective equivalent temperature and morbidity for the whole area. And high correlation coefficients of health indicators with a thermal discomfort is expressed by bioclimatic index confirmed the assumption about the climatic determination of the population health, and people with respiratory disease is the most vulnerable group of the population. As the conclusion for the first part of my presentation, the relationship between climatic discomfort and the regional specifics of the respiratory pathology in the Russian Far East is shown, and we can see most severe climatic conditions are reflected in higher respiratory and circulatory system morbidity for the northern regions, for the entire population, and for the children and adolescent age cohorts. And in the Arctic, the older generation practically doesn't take part in the formation of mortality, which reflected in its relatively low indicators. One more issue about which is very important for the Arctic, aspects of travels and acclimatization during the travel. Powerful Arctic images magnetize people from all over the world. Ship-based tourism, which includes landing and non-landing times, is the most common tourism category in Arctic. In cruise tourism, Russian Arctic National Park is one of the main promising tourist enlarged investment projects with cultural, educational, and environmental aspects of tourism. And no one permanently lives in the Russian Arctic National Park, so you can imagine it's pretty wild. In 2019, we are talking about this year, for 2020 was an unusual year, 5 tourist companies operated in the Russian Arctic National Park, and 1,300 tourists visited the Russian Arctic National Park from Russia, China, Germany, Switzerland, the US, as a whole from 44 countries. The 50 Led Pobeda, the most powerful nuclear icebreaker, made 5 return voyages from Spitsbergen to Franz Josef Land, from Murmansk to the North Pole, And the Sea Spirit, another ship, made 3 return voyages from Spitsbergen to Franz Josef Land. During the season, visiting tourists took trips to Franz Josef Land's 15 islands, those with the most representing and interesting locations of the Arctic archipelagos in terms of geology, flora, fauna, and cultural heritage. The national park scientific research include the monitoring of the polar bear population, describing botanical and geological peculiarities of the various islands and in the archipelago and others. But we should think and know that extreme climate in the Arctic region tends to exacerbate problems of tourism development here. It is well known when contrasts in climatic environment increase, the intensity of the adaptation processes becomes more pronounced. A change of setting due to travel between places where climatic conditions are different will have a physiological cost. This cost is a period of short-term acclimatization during which the body experiences added thermally induced physiological strain that affects physiological well-being during the period of adjustment. Acclimatization thermal strain index describes the additional thermal loading on respiratory organs until full acclimatization is achieved. It is defined as the ratio of difference between respiratory heat losses, the index with what I was talking about at the beginning of presentation, for the acclimatized and non-acclimatized individuals expressed as a percentage. The further advancements to the ATSI scheme have produced a normalized index called the Acclimatization Thermal Strain Index for Tourism, which uses the body environment heat exchange that takes place during the acclimatization process to calculate the consequences of contrasts in climatic experienced after travel for tourists or anyone traveling to a place where the climate is different from what they have and their home locations. Based on research of physiologists, we suggest that the possible physiological responses during adjustment process can be described verbally in diapason from low, moderate, significant to high and very high. This helps to characterize the degree of acclimatization thermal loading on the thermoregulatory system and acclimatization process of a person during transboundary travels. To illustrate the utility of ATSIT, the consequences for tourists traveling internationally between contrasting climates are examined for both summer and winter conditions from the Russian Arctic National Park to different attractive destinations. The results for summer on this slide show that human body is subjected to excessive and large acclimatization load when moving from the hot and humid conditions, let's say Miami, Singapore, or Haiti, to the very cool summer Arctic. For comparison, the results of calculations for the capital cities of Russia as well as northern Murmansk are presented, moving from which to the Arctic zone is characterized by weak and minimum adaptive strain. The harsh environment of the Arctic zone imposes specific requirements on local residents, newcomers and indigenous people, but especially for those who are here on a short visit, when significant differences in the new weather and climatic conditions from the usual ones can considerably increase the acclimatization load. And these calculations are based on climatic data, and you can imagine how high this can be if we take not climate but weather data. Let's say climate mean temperature in summer is plus 20, but it can be as high as 30 degrees, and acclimatization load can be much higher. At the same time, It is necessary to take into account the acclimatization load experienced by the Arctic residents who want to relax or improve their health during winter season. So now we are moving to winter, and the results of calculations for travelers from the Arctic zone to potentially attractive destinations worldwide are presented here. When moving to a destination, Arctic residents will feel quite comfortable since the ATITs do not go above the low and moderate level. These results will not cause concern to a healthy tourist, but it is necessary to be wise when planning such trips if the person is unhealthy for any reason. Moreover, it is extremely necessary to consider the possibility of such travels, which can result in acclimatization load from high to excessively high when getting back to the place of permanent residence. So when you're going from winter to summer, it's not bad, but when you are going back to winter, it's really can be dangerous. Moving in winter from hot humid, we should think about humidity and how it will reinforce the conditions. Moving in winter from hot humid conditions, let's say Miami or Singapore, back to the Arctic is expressed by a stronger adaptive stress than from hot and dry conditions in compare with Melbourne or Buenos Aires. And in conclusion, we can see that ATSI projections, such as those presented here, provide travelers with information that led them to predict the level of discomfort they might experience at a new place during acclimatization period. Preliminary calculations can be used when planning the route and time of transcontinental movements according to the criterion of the minimum acclimatization load. And just at the end, instead of thanking you for listening, as Vice President of International Society of Biometeorology, a few words about this society, which provides an international forum for promotion interdisciplinary collaboration between people or scientists of different specialities. We have different commissions. I'm part of Climate Human Health Commission and Climate Tourism Recreation Commission. Another two, Animal Biometeorology and Phenology, and Students and New Professionals Commission. We have our International Journal of Biometeorology, and we hope that you will be interested in joining us in our International Society of Biometeorology. Thank you.
Thank you so much, Elena, for your wonderful report. I think you can also, if you could share the links other than, well, clickable links from your presentation in our chat. I could also make it available later to everyone who participated in our overall report. So that would be great. If anyone has questions for Elena, anyone in the audience or panelists as well, yes, Alexei, you can also ask a question. And if anyone from the audience has one, please drop them in the questions and answers box. We will get to it later. Yes, Alexei, go ahead.
Yeah, I have one short question. Thank you, Elena, for nice presentations. You presented many equations and formulas. Could you please explain how did these equations been derived? I mean, is this empirical data or modeling data from climatologists or some statistical approach? Could you please clarify a little bit?
Yeah, thank you for your question. Yes, it's modeling. Unfortunately, we have this index should be verified, and we are welcome all those who can help us with the verification of this index. That means let's say, surveys of people, those who are traveling on contrasting climatic destinations. Let's say those people that are living in Arctic, that are traveling abroad, and when they are getting back, asking people, or would be very interesting to join with scientists that are working in Antarctic. That would be really very impressive to know how they feel when they are getting to Antarctic and when they are getting back. The only reason that probably it will not work with Antarctic for those who are working there are mostly healthy people. And the concerns that we are talking about today are for those who probably have some sorts of health issues, health problems. That's really a question for them. On my main experience, it's not enough to verify the index, but I know definitely for myself, I had a lot of traveling in last days from Khabarovsk in winter, Khabarovsk, which has really a very harsh climate in wintertime, -30 with strong wind is just almost every day in January. When I traveled to Australia, that is summer at this time, with +30 degrees, it's not a big deal when I am getting to Australia. But every time, and I was in Australia quite a few times, when I was getting back, I felt ill with my respiratory every time. That's it's not enough 10 cases of my own experience. That's why I welcome those who can help me. The most important would be to take these special devices, medical devices, those that use respiratory health medical medications for breathing volume, for all other calculations, to have all this data and to look at this data and have these statistics. So if you have, would be really good. Thank you.
Okay, thank you, Elena.
May I ask one? I'm just curious, just for fun. I'm not a scientist like you are, but I'm curious whether I share your feeling when I go from California in January to Moscow. When I arrive, I definitely, it's partly must be the time change, but the temperature change is huge. But another change, say from going from Australia in summer to Khabarovsk in the winter, surely must be the difference in light. Does that have any effect on the thermal transfer? That is a person going from a lot of natural daylight to very little. I mean, Khabarovsk in January probably has very short days, not to mention the wind and the cold. So how does that need to be factored in? And if it is factored in, how would you do that?
It's not for Khabarovsk. Khabarovsk is the same latitude as Paris or Sochi. It's just the same, 47, 48. Sochi is a bit further, closer to equator.
Then let me convert my question to those who are going
to the north. Yes, it's another aspect. We are not. It's not about thermal loading. It's light, different light, and I guess that Mikhail will talk about this. Or
yes. I plan to describe some things. Yeah.
Knows much more about this aspect.
Okay, I'm relieved because I need help in both instances. Great.
And I can see that the question was, or something from I can't see the
Alexei shared some info.
I shared some studies of our colleagues from University Faculty of
Ah,
Geography. We have
yeah.
one working group which is focused on human perception of weather, of weather conditions, and I think you certainly should contact this team because a lot of scientific outcomes from their research, and this would be very essential for you, I think.
Yeah, thank you very much, Alexei. I know well this group. I know Pavel well. I know all those who are working with him, and they are working very close with Pavel Alexandrovich Revich. And I know these researchers and their what they have. Thank you. I know them. We are working pretty close with them.
I also have a small question in regards to your presentation. There was this discrepancy, right, between the mortality rate in Chukotka, and then there was the Jewish autonomous region was incredibly high, so as opposed even to all the others. So do all those elderly people from Chukotka travel mostly there, or what's the reason for that?
I don't know. No, definitely they're traveling to many other regions, but mostly to Amur region, Khabar, Primorsky Krai, those which are located at the north. That's the first gradient from north to south. And after that, they are moving from Far East to European Russia. But what about what I know about these moves? First, they are going to from north to south. But sometimes, if they have, if they can, they move straight to European Russia. And that's why all these people that were living at the north, afterwards they go with all these issues of illness. They are moving to other regions and getting there, they have all these disease. Actually, I know well the situation in Krasnodar and Krasnodarsky Krai. They have really big issue of people from the Far East, like big migration trend from Russian Far East to Krasnodarsky Krai, and they are really concerned about old people with all these problems, health problems that are moving to this region of Russia, and they are really all health indicators are getting higher, especially mortality.
Yeah, in Krasnodar, I think it's applicable not necessarily to the northern travelers, but sometimes even to people from the central regions, because I used to get ill all the time when we would travel to Krasnodar in summer, and they would I had a few doctors tell us that, oh, you know, like from your particular, well, our particular zone was in the Chernobyl area, affected a little bit by the Chernobyl area, but they would also say that you don't really need to travel here for vacation, because that's a regular thing, all those respiratory diseases, and especially for the children. But yeah, I was just wondering why the difference between morbidity, like respiratory morbidity, and mortality in the Jewish Autonomous Okrug was so high, like really, really huge difference.
This another aspect of health issues in Jewish Autonomous Region by itself. It's another social problem that we have not very good medical assistance in the Jewish Autonomous. Living there, living in Birobidzhan, I know this quite well. It's really a big issue, big problem.
That's what I thought. Yeah. Okay. Thank you once again, Yelena. And if there are more questions from the audience, feel free. if you have a question that you forgot to ask right now, you can drop it into the Q&A box and we will address it later during our post-panel discussion if there is anything to talk about. Or Yelena can also check the Q&A box herself and answer your question if you have one. So feel free to ask. And I think we can move on to the next reporter. Thanks, Yelena, once again.
Thank you.
So our next report is titled Thawing Heritage, How Permafrost Degradation Affects the Bering Strait Coastal Communities by Alexey Maslakov from Lomonosov Moscow State University. Alexey, go ahead.
Thank you. Can you see my presentation?
Yes, yeah, we can.
Yeah, fine. Good day, everyone, once again. Here I'd like to say, I would like to present you some of my studies on how permafrost degradation affects coastal communities of the Bering Strait. And since I'm mostly a permafrost researcher, so my presentation will be focused on permafrost issues, but also on how this phenomena is affecting well-being of local communities. So you can see on this slide one of the examples of permafrost thawing. You see hammocks and a lot of garbage. So this place is a place where permafrost degrades. And this house on the background, this is ice cellar in permafrost, which has already been collapsed due to permafrost thaw. And I will tell you about this a little bit later. So Bering Strait is a boundary area between Russia and the United States of America. And this region is inhabited by local people, Chukchi, Yupik Eskimo, and other indigenous people of the Arctic. They have been living here for hundreds of years, and actually from both sides of the Bering Strait, they have relatives from each other. And before Soviet Union government establishment, there were numerous crossings of the border because people just were walking on ice to the neighborhood communities, just visiting them and visiting their relatives. So after that, that region was separated by state boundary, and this connection has been lost. Moreover, in ancient times, this region was a part of greater land called Beringia, with single environmental conditions. So these communities are built on the similar sediments and have experienced the same problems when permafrost thaws. First of all, some information about climate change in this region. You can see in blue round this region of Bering Strait, and the maps of climate change, of air temperature change for the last 40 years. And the temperature have been increasing for 3-4 degrees Celsius for this time. And if you see meridional mean for the whole Earth, we can find that almost all latitudes from South Pole to the mid latitudes of the North Hemisphere have risen for 0.5 degrees Celsius. Meanwhile, in the Arctic, the temperature has increased for 3 degrees. So I can state that for the last 40 years, temperature in the Arctic has increased with triple faster speed than the whole world. And if we see in absolute temperatures, these Arctic latitudes have experienced warming for 2 degrees Celsius or more. And these temperatures changes are affecting sea ice cover. And here are some examples of sea ice cover extent in the Arctic for the 2018 in compared to median values in 1981 to 2010. And you can see that both winter and spring in summer sea ice expansion has the most noticeable changes in compared to median time, especially in the Bering Strait region. Here and here we see the big difference between median time, median border and the border of actual edge of sea ice cover. And the satellite data confirms our confirms these trends, and we see that sea ice extent in September is decreasing both in Chukchi and Bering Sea. And this affects the local communities very significantly. I'll tell you about this on the next slide. First of all, let me say the most interesting outcome of my research. This is a state of underground ice cellars. The ice cellars, they call it in Russia ledniks, and these are chambers or corridors dug in permafrost for food storage during the whole year, especially in the summer, when the people need to be provided with food and for fur farms. Because almost every community in Chukotka has their own fur farm for polar foxes, and they must be fed for all the year by the bees. Now, so we have been studying this the state of these ice cellars in almost every community of Chukotka region. You can see this map, and unfortunately, by the 2020th. We have only 2 ice cellars remained. The other ice cellars, community ice cellars, have been collapsed due to climate change and due to some problems with engineering solutions of these ice cellars. And the largest ice cellar is located in settlement of Lorina on the coast of the Bering Sea. You can see on the left upper side the aerial view of this community. This is the largest indigenous community in Chukotka. And nearby from this community, we see the polar fox fur farm, which also needs a lot of food for feeding the polar foxes. And on the right side, you can see the scheme of this ice cellar. This is the largest underground food storage in Chukotka. Its length is about 114 meters long, and the total square of chambers is about 330 square meters. You can see how it looks inside. The walls and the roof are covered with ice, and this place is for food storage of this ice cellar. The other ice cellar from different from other settlements have a worse fate, unfortunately, due to climate change or human mistakes in engineering. This ice cellar has been collapsed in in two reasons. The first reason is flooding, since underground water goes to the thawing permafrost and flooding the chambers and corridors of the ice cellars. The other one is just collapsing of permafrost, just warming, thawing, and collapsing. You can see this is ice cellar in Incheon settlement, which was destructed in 2019. And even in 2017, we have noticed that the walrus meat was already covered by mold, and it was spoiled. People could not use this meat for their purposes, couldn't feed themselves and polar foxes for the farms. And after 2 years, this ice cellar was just collapsed and people lost this facility forever. At the same time, in Lorena, the ice cellar is still stay because people doing some measures for its preservation. First of all, this is winter ventilation, passive ventilations with cold winter air. In this graph, you can see the change of temperature within the chambers of the ice cellar in Lorena during the whole year. And you can see that when winter starts, they open doors and open windows and other holes for passive ventilation. And you can see how drastically temperature drops just up to -16. And this ventilation cools permafrost around the chambers, and it decreases temperature by the end of the winter for 4, 5, 6, or 7 degrees, facilitating its stability. During winter, they also accumulate river ice blocks in the chambers in order to increase heat inertia during summer. And of course, every several years they have renovation works, and every summer they're cleaning their ice cellar. So in Lorena, everything is pretty much well, not as bad as in Chon, for example. And these people are still keep this facility working. Another problem is coastal erosion. Since all communities of the Bering Straits are located on sea coast, they're experiencing wave action. Here are some my examples of coastal facilities destruction in different communities. You can see the erosional bluffs. This is a feature of coastal erosion, of erosional coasts. And almost all communities are experiencing this problem. They lose their territory, the destruction of coastal facilities, etc., etc. The same problem is in Alaska. Here are some examples of coastal erosion in indigenous communities of Western Alaska. And on the left upper map, you can see the communities which are experiencing problems with losing of their territory due to coastal erosion. Here are some forecasts stating that, for example, for Shishmarov community, by the middle of 21st century, some streets and houses of local people will be destructed by coastal erosion. And our key study site is this community of Florina, which is located on the Chkhotka site. And you can see the aerial satellite imagery of this coast and changes of coastal bluff edge since 1967 to 2017 for the last 50 years. And the average coastal retreat rate was 0.4 to 0.9 meters per year, depending on location within the communities. And if we see the temporal dynamics of this phenomena, we can see that for 60s, 70s, 80s, and even 2000s years, we see not very high rates of coastal erosion. While for the recent 10 years, we see just drastic increase on this parameter. And if we compare with average 50-year coastal erosion rates, we see that in recent years, although we have some decrease in coastal erosion rates, they are still very high and still threaten to coastal facilities. We calculated on how it be linked with sea ice extent and wave action, and we calculated wave energy index, which is the mass of water coming to the coast, and we found such a negative trends for Lorena, for Shishmarov communities, and these trends here below. One of them, the biggest one, is for Lorena. This means that every 10 years, heat wave action is increasing by 22% for Lorena. For Shishmarov, 88.5, for Orlen almost zero, and for Kivalna, some slight decreasing of wave action. How it expressed in the coast? You can see the picture of the coast in Lorena. It's 2001, very wide beach, very high beach with boats, constructions, people on there. You can see grass on the coastal bluff. And in 2012, this is the same place, almost absent any beach, no any grasses there. You can see that the morphology of this coast has changed, and people cannot use this area for their domestic activities such as fishing, hunting whales, using boats for traveling, etc. And in 2017, even more drastic changes. You can see that the building now has appeared from this point of view. It was absent here, now it is visible. And maybe in 5 to 10 years, this building will be destructed by coast. Another phenomena is active layer thickening in Arctic, in permafrost regions. Active layer is the upper soil layer which thaws every summer. We have two monitoring sites here in framework of Circumpolar Active Layer Monitoring Program near settlement of Lavrentiy and near settlement of Lorna. Here, these red rectangles. You can see them on site, and the active layer measurement is quite simple, just probing thawed soil by iron rod until it touch permafrost. After that, we measure how deep is the thaw of this soil. And our observations have noticed significant trend in increasing of the depth of soil thaws. And this happens with the velocity of up to 1.5 centimeters per year. So you say me, so what? The problem is when active layer is increasing, it thaws permafrost. And when permafrost is thawing, it produces not very good exogenous processes. First of all is gully erosion, gully development, and thermokarst and thaw slumps. You can see this phenomena, they occurred just in recent years due to very deep thawing of soils. Of course, this is a problem for local communities because they cannot travel here by ATVs, for example, as they have to find bypass in order to travel from one point to another. Another problem is the lowering of soil surface due to melting of ground ice. And my personal observations calculate that for the 7 years for monitoring site Lavrentia, we have decreasing of soil surface up to 15 centimeters, just go down without any increasing up. And in order to demonstrate these changes, I would like to present this figure. You can see how we have a borehole for sensors, for thermal sensors, and you see that from this every year, this road has rising up from the earth because the surrounding permafrost thaws and the soil surface has decreased. And we also forecasted what will be in the future with the active layer. And our calculations demonstrate that by the end of 21st century, we will have increasing of active layer seasonal sowing depth by 87%, depending on the forecasts. We have different forecasts, negative, positive, and average. So due to after negative forecast, we have increasing of active layer up to 87%, and surface lowering will be by 500% in compared to current active layer thickness. So these changes are very, very drastic, and they cannot, they will certainly affect local communities' activity. Since a lot of facilities in these communities are built on permafrost, and they depending on permafrost conditions. And even now, we see these changes. First of all, this gully development, this water logging, thermokarst, deformations of building. If you see on this picture, you see that this building has some deformations. It's due to lowering of soil surface. And we conducted some geophysical works and established the distribution and found the distribution of active layer thickness in the Lorraine community. And we see that the active layer thickness is 2 or 3 times higher than for surrounding areas. And under some houses which were constructed in the middle of 20th century, we see that those zones of permafrost occurring the whole year. So permafrost don't form under these buildings and still grounds in thaw state. We also tried to compare how our results correspond to local opinion, and we had questionnaires among local people who have been living in this area for more than 30 years. And here are some results. We see that 40% of respondents note negative influence of permafrost degradation on their houses. They see cracks, they see waterlogging, deformations of buildings, and some problems with their houses. They also notice some hazardous phenomena. 64% of respondents know the warming during winters, so thaw events during winter when temperature increases higher than 0 degrees Celsius is very dangerous for reindeer farming because reindeers cannot find the lichens and the other food after this crust of thawed snow is turned into ice, and they are dying in a lot of in big numbers. And some people also notice that some southern species invade their environments. They see the birds which never been seen before. They see some plants, and well, this sign is very noticeable for them. And in order to sum up my studies, just some bullets for conclusions. So permafrost temperature increasing makes ice cellar, the food storage in permafrost, unstable, and thus deteriorate food storage conditions. Well, coastal erosion acceleration in recent decades also threaten coastal facilities, and some of them have already been destructed. And this is also not very good for these local people. Active layer thickening, which was noticed for last 220 years, it provokes thaw slumps formation, thermal erosion, and thermokarst processes that impair movement on tundra by foot and ATVs. And permafrost degradation within communities facilitates waterlogging, gully development, and buildings deformation. So what's next? What's next with this phenomena, with these changes? First of all, it is very clear that permafrost degradation caused by climate change leads to additional financial losses in local budgets. So local governments are experiencing increasing loss for restoration works and for maintenance of current infrastructure. For example, ice cellars, because they're collapsing and they require more attention from people. And some communities have already changed ice cellars into electric refrigerators, but these refrigerators are consuming additional fuel, which requires additional money for transportation to these remote areas. And the governments are discussing the plans for communities' relocation to to safer place. But this safer place is less convenient for local people since they have been living there for hundreds of years. Their ancestors have been hunting on mammals, on walruses, on the whales there. And these places, of course, is their heritage because their ancestors are buried there. And they have a lot of cemeteries there. So, of course, the governments are developing plans on climate change consequences mitigation and adaptation. How can they adapt to these changes? What should they do with this? And of course, this is a big issue for this area because local people living here, they've been living here always. They don't have any other place to go. For example, if Russians go into the north for mining, for earning a lot of money, they always can go back to the central Russia, to southern regions, to their relatives. But these people, this is their land. And unfortunately, they have nowhere to go. So I have finished. Thank you very much for your attention. Sorry for my spelling problems. I am just a little bit exciting. Yeah, I will be glad to answer your questions.
Thank you so much, Alexei, for such an exciting report and for being excited in presenting it. I think we all appreciate it. So much data, so much interesting information in general. So yeah, if anyone has questions to Alexei from the audience or the panelists, you're welcome to ask them. How long have you been researching that area in general?
I have been working there since 2012. So this field season will be tense for me. And even restrictions don't stop me to get there, because we have to conduct monitoring. We have to measure active layer. We have to measure temperature in ice cellars, and we have to check what have changed since last year. And people, I meet them, I talk to them, and they all say that, yeah, the weather has changed, the nature has changed, it's very warm, it's very unstable weather, and of course they are also, they are stakeholders in this situation, because they are very interested in saving their environment, in saving their houses, in saving their style of life. And my duty is to present these changes to broader scientific audience, to local governments. And this problem is very complex. You see, climate change affecting permafrost change, and permafrost change affecting local people well-being. So this is a complex problem. Yeah.
Yeah, that's true. We have a question, an interesting question. If there is any help from other countries regarding technological equipment or financial supply to promote the realization of the plans that you mentioned in your presentation, if there is any help.
The other countries were helping to these communities, especially the United States, because this is neighboring country, and a lot of people, a lot of relatives of these people are living there. But this help was moderated by food provision, providing food and engines for boats. And of course, government, especially government of Chukotka, thinks that they are boundary region and they have to be very aware of any help from the abroad, because you know, this is a heritage of KGB people, and they think that we don't have friends from the abroad, we have enemies from abroad. And fortunately, the help is very, very moderated, especially recent years. And if someone from abroad visits this place, he must notify local border troops that he's here, and they, well, they are looking for him for every day. So development plans, well, this is duty of local government, of course, of Russian government.
Yeah.
I think. But I think it's very interesting to compare the approach which Russian government and U.S. government use. How do they cope with these changes? What do they do? How do they adapt to these changes in these communities? And it's quite interesting because some communities in Alaska have already been relocated. They used a lot of money for just resettlement of these people.
Thank you. Any more questions?
I have just one comment to Alexei. Alexei, thank you very much for your really very interesting presentation. I know that you are a permafrost researcher, but it was really good that we asked you to show your results in our session, for it's showing us social content of those changes that are going in permafrost. So social results and how what happens with societies, with people that are living in these regions, in northern regions. So thank you very much for joining us at this session.
Thank you for listening. Thank you.
Okay, are there any more questions? If there are no more questions, then we thank you, Alexei, once again, for the presentation, for staying with us. Sergei Kalimichuk comes next. We need to try if he's there.
I'm here, yes.
You're here. Do you have
Yes.
a video with to?
Well, I just tried to do that. Sorry, it's maybe very slow connection. It's just okay. It's me.
Perfect. Yes.
And yes, yes.
Great. Okay, so I'll introduce you, and you can present next. So
Yes.
Sergei Kalimichuk from Institute of Biology, Karelian Research Center of the Russian Academy of Sciences in Petrozavodsk, will present a report titled Seasonal Changes in Melatonin and Cortisol Levels and Sleep Parameters of Primary School Children in the European part of the Arctic territory of the Russian Federation.
Yes,
Sergey,
yes.
thank you so much. Go ahead.
Yes, just thank you very much for such opportunity to make my presentation at Fulbright. And I do appreciate all the organizing committee and all the people who also contribute to this conference. So it's a big pleasure for me to be a part of your conference. So just quickly introduce myself. I'm a senior research associate at Laboratory of Genetics at Karelian Research Center, Russia Academy of Sciences. So I got training in US previously by postdoc training in Arkansas, University of Arkansas for Medical Sciences. So I'm just now in March Madness supporting our team, Arkansas Razorbacks. So we just qualified to second round, but it's quick. My topic is devoted to mainly biochemical and physiological responses on how children react to the environmental changes. And we have complex project. So it's devoted mainly to Russian, European part of Russian Arctic. So just sorry, it's a bit in Russian, but I just try to explain it. The main thing, the main thing that pediatrics are faced at when the children go into the doctor, they have only some sleep complaints. That all complaints are mainly in nervous system, sleep complaints, and gastrointestinal. So it's many years detected by pediatricians in different parts of Russia, and mainly in north of Russia, because the territory is located more than 40 degrees of latitude. It's represent most of territory of Russian Federation. So all these complaints are of sleep complaints could be divided in several things. Like it's hereditary, like here, psychophysiological, related to damage of central nervous system. They also connected to alertness and neurosis, hormonal changes during puberty, and also sleep light, excessive light affection by in cities. So that's why they quickly introduced and the actual things about our data is the sleep quality and the duration are related physical changes in children and adolescents. So also, if you sleep 8 hours or more, like have in blue, that's normal, and that's okay, and no differences between children with normal development. But if you have less than 8 hours, that's what detected in Moscow when it was 1,585 children of 12 to 16 years old. You have to prone that not obesity, but excessive body weight. And also sleep deficiency is correlated to physical development of children. And that's why we have pointed out our main tasks that have frequency of different sleep complaints in children of lower, of younger children, school children, from 7 to 12 years old. Why we need to use this target audience? Because first of all, less somatic mutations, less of different diseases detected, lower mobility of children, and it's very convenient to make a first step of survey during at school in different places. So also we have to make links between sleep patterns and different factors like academic proficiency, like habits, alcohol use, and nicotine. So we have school children as subject, and we have several patterns of behavior and sleep quality. So the workflow of our project is like we have first of all a small trial on 100 persons in Petrozavodsk when we are located. Second one, after we have the first part of it, because we need to have assess some questionnaires, for example, pediatrics daytime excessive sleep score, which have adopted from Chris Drake from Detroit. The next one, after we validated that and we have presentation about that, we expand our study to bigger sample, not only in Karelia. We have to move to northern part Karelia and Murmansk region too. Also in some of children who reside in northern part, we have biochemical and genetic studies. The outcome of this, why? The main thing what we did that we have to elaborate reliable, non-invasive, and simple protocol of evaluation sleep patterns, and it links between sleep complaints and hereditary status, biochemical, and several habits. So material methods, different surveys. So we have more than in total more than 1,000 persons who equally distributed between female and male. Physical activity was quite normal, 70%. Most of children have use caffeine in like cola, soda, and tea or coffee, but some rarely. Alcohol use was quite normal for this part of children, like only 7%, and smoking is detected in minimum. In geography, we have used in red in Murmansk region and Olenegorsk, Apatity, and Mumba. Karelia is northern part is Kostomuksha and Kiem, which mostly residence for local people and named Pomors, who reside there since 10th century. And for control, we have people who live here in Petrozavodsk. It's mixed population between Russians, Karelians, Finns, and Veps. So we have, first of all, we have a pediatric daytime sleepiness score. It's mostly related to excessive sleepiness in children. And this part is lower than for other populations because we have children of lower age, and this is normal. It differs from Brazil and from US, and the main difference is the age of children, because it's the first time we have to assess children in sleep from 7 to 12 years old. So if we have age dependence curve, we have such dependence that we decline till 12 years old when puberty starts. And this group, we have 10 to 12 to 14 years old, because this is the minimal amount of children who make surveys. So we group them together, and after puberty, the excessive sleepiness. It means that children have to compensate shortage of night sleep during the day. That means the excessive daytime sleepiness. It again comes grows when puberty progress. And also we have parameters like not only anthropological parameters or no sleep parameters like inertia and latency of sleep. Most of parameters are not different. Like it was surprisingly, but sleep inertia and latency, which could be different, it's not different. They have not been difference between children because it could be explained when we have children in rural area, they all have good sleep quality. And how sleep parameters affect on academic success. We have to admit here that children have different chronotypes. It means they temporal activity. Some people active in the morning, other are active during the day time, and the rest of people are active in the evening time. They call larks, owls, and intermittent like doves. So it's more complicated now, but I couldn't see no points in this discussion. And if we stress out here, if we sleep, if you are a later chronotype, you have to accommodate to earlier schedule. You have low success, a low academic scores, GPA, then earlier chronotypes, and then intermittent. So we have also detected several parameters, like most of it in sleep awakenings during the nights. Most of children are have low subjective estimate of sleep, and sleepiness is like 15% in this group. But I could stress out that most of sleepiness comes to children of pubertal age, and sleepiness, the some insomnia scale, like they are quite light at like 40%, no more. Well, how sleep complaints and sleep disturbances are linked to other factors, some bad habits or some drug use. So most of it, we have about awakenings. So caffeine use is quite good association. So the more caffeine you use, the more awakenings during the night and lower sleep quality you have. So some neurological pathology, if you have it, also showed here. If you have bruxism, it's like you have teeth scratching and teeth during the night. So you have neurology also connected to neurology pathologies. And if you have some medications using children, like medication to support life conditions, also have here. So nightmares are connected to caffeine, again, caffeine use and medications. So the same as have to some movement during the sleep. Do we have detected any peculiarities related to the place of residency? Of course, we have. If the more things we detected here is connected to the place. This hypothesis about low chronotypes are located up north. So here we see that chronotype, for example, we have some sample from local people, Dolgans and Nenets from Dudinka, Krasnoyarsk region, and from Tyumen, it's lower here. And the chronotype is going, if we have more here, I could explain. We have 5, it's more than 4. If chronotypes have bigger, the more we have in numeric amount, the more the later chronotype is. Chronotype is like a middle phase of sleep, if we have in first approximation. If we have more, like 4 or 5, it means that a middle phase of the sleep goes later, and you have to take more effort to be awake in the morning, because the school starts at 8:30. And if we have, like here in Petrozavodsk, for example, and compared to Murmansk region, also the chronotype is half hour more. So the hypothesis works. So if we have higher latitudes represents later chronotypes, is one of it. For example, physical activity it also have the difference. Here we have local people, means Pomors who reside on the seashore of White Sea, Pomors. In comparison to mixed population, Petrozavodsk, they have more physical activity. And here is not represented data on Apatite, which have almost migrant population. In Apatite, physical activity is lower than for Aboriginal people. And here we could admit people from Dudinka, it's Dolgans and Nenets people, because they live not in their normal condition. They live in how say, they're not adopted, but they live in internat. So the house they placed, they collected from tundra and live in the house during academic period. For example, first and second semester during the school, they live in this house, not with their parents. That is one of the reasons they have so low not physical activity. And the emotional activity is the same. We see here, maybe it's one of explanation. Restriction to the from natural conditions explains such emotional state. How all these parameters are linked to biochemistry. For example, here we have one of the stress hormone. Is also represent awakening hormone, is cortisol. And we measured them by ELISA. It's biochemical assay. It can detect in blood, in urine. But for children, I could see we use only non-invasive methods. So we use saliva from children, and we took it from specific point from awakening, and we have 3 to 5 points in each children, 2 special caps, collected, then analyzed. And I could tell you that children who represent Aboriginal, they are more response to the awakenings. Awakenings easier, because the dynamics of the curve from the awakening hormone is goes quite sharp. And the same we could see about sleep hormone, melatonin. I can say that melatonin regulates day and night. And most people who came to the north as migrant children, they are have some sleep complaints. It's why we try to have the answer, and we measure melatonin in urine, not in saliva, because in urine it was easier for children. They explained that in saliva they missed some points, and we gave them caps, and they have twice measured melatonin during the day and at night. melatonin was collected at dim light conditions. So it means a lower intensity of light do not disturb melatonin secretion. What we found here, so in females, melatonin is higher than in males. And during the day, melatonin was almost basal level, very, very low. And in males, it's all less than in females. So what main factors would during by the analysis of ANOVA pointed out that it connected to the sex of children, it connected to the place of residence, migrant or aboriginal. It's connected to the time of the day, of course. And most of it, day and night, if you have this more interaction, and both sex and the place of residence show the statistical significance. So again, together with our colleagues from Kola Science Center, we represent data that sleep parameters affects by some biochemical. So if, for example, low sleep length increase the glucose level in the blood of the children, but it's mostly related to children that lived in Umba. So children lived in Murmansk region. So and some other things, for example, if we have here desynchronosis, it affects the phosphorus, which mainly connected to the bone status and the physical development, like the magnesium, for example, here too. So related to stress. So it means if you sleep less, you have a lower level of magnesia, and so on. For example, cortisol correlated to DNA, to genetic markers. One of the markers with, related to early awakenings, and previously was shown by a group from Surrey University. And it's, for example, a period, a circadian gene, and have variable tandem repeat. It's also statistically significant. Cortisol level was higher in larks and in intermediate chronotype who had some specific allele, like 5 means you have different regulation of sleep homeostasis. For example, and a bit more than my limit, I had to conclude that sleep disorders associated with of bad habits, cortisol is reduced in if you have a specific marker like period circadian gene, dynamic, time response curve of cortisol differs in children who migrant and aboriginal. And also melatonin depends on gender and place of residence. So sleep duration affects some biochemical parameters in the blood of young school children. And special thanks to our team. It's a team from Petrozavodsk, Petersburg, and the Kola Science Center. And special thanks to people, not only in Russia, and also University of Surrey, and Christoph Randler. And also we have our new collaborator, and Chris Drake from Detroit, Michigan, sleep division, who's sleep doctor, and also helps a lot with the questionnaire, with analyzing data and writing the papers submitted to good peer-reviewed journal. Thank you, and the work supported by some Russian grants. Thank you very much. Questions, please.
Yes, thank you, Sergey. Thank you so much. Feel free to ask Sergey any questions, our attendees in the audience, or think about the questions you want to ask maybe later after the last presentation during the post-panel discussion. So feel free. Or if you want to join the post-panel discussion as a panelist, let me know in the chat and I will promote you to panelist if you have something to add or maybe to engage with the panelists in their discussion. I don't see any question at this point.
Can I ask a question?
Sure.
Yeah. Sergey, what do you think about a school start time? Should it be changed in the Arctic schools or not?
Thank you, Michael. Good question. And we discussed that with Russian colleagues and American one, like Chris Drake. And we see if we have some examples from Finland, from Denmark and Norway, it's up to local authorities, I think, if it could be changed only in second semester from October and to December. But as we have examples, academic success not greatly affected by that, maybe 5 or 10%. It's like not statistically significant, even Los Angeles, but it's maybe not so very good example. But I think we need to have to try that. And we discussed that with people in the KM, it's Arctic Karelia, they have to, Ministry of Education Karelia should approve that documents. We put all our arguments to the table, and on the sleeve, all our jokers in the ministry now. And now it's up to them to decide, Michael. So that's my response.
Thank you.
I think we should try that. It's a good idea, but only for that time when daylight decrease.
Mm-hmm.
Only
Okay.
after that we could analyze 1 year or second one, and need specifically we need to have some actimetry, for example, objective control of that situation. So people have to wear some devices, and we need to prove that not only by a survey, because survey people describes the situation, and if you have the device who controls all your internal rhythms and sleep quality, that's the only way to make data sound. That's what I see.
Thank you, Sergey.
So, thank you.
So, any more questions? No? Okay. Okay, then we will move to our last presentation for today's panel, somewhat linked to Sergey's. The presentation titled "In Search of the Best Work Schedule During the COVID-19 Pandemic, How to Improve Health and Mood in the Arctic," presented by Mikhail Bochkarev at the Almazov National Medical Research Center in St. Petersburg. So, Mikhail, go ahead. Okay.
Yep. Thank you for all the organizer and Fulbright community, and I would like to tell today some things about work schedule, and this situation became mostly important because of the last COVID-19 pandemic. And it's quite interesting situation because we have some examples and lessons from the Arctic community. First of all, I would like to start and remind that in 1926 year, Henry Ford changed some of our life and introduced 40-hour work week. So he told that we don't need to work more because it doesn't increase our productivity as much as we expect. And it's not a real situation, especially in medical staff. Many people have 1, 2, 3 jobs, and they have maybe 80 or 100 hours a week. So it's not the best thing. So Spain, in the beginning of this week, they launched a trial of 4-day working week. So I'm very glad of it, and I hope that our country will follow these trials. And they expect that people will reduce absenteeism, they will rise productivity and will be happier hope they will be happy even living in the Arctic. So what are features of living in the Arctic, especially thinking about schedule and different daylight? So many people live in small cities and they start their job at 7 or 8 a.m. or even earlier, and of course finish earlier. They have seasonal changes in daylight and polar day and night in cities higher than 69 north latitude. As example, 40 days polar day and night movements. And this activity changes during the winter and summertime, especially in the indigenous people, but it's not clearly understood at present time. Working as a sleep and chronobiology researcher, I'm always thinking about what affect our sleep and wake cycle and how our life entrained by different things around. So the most important thing is daylight. So daylight goes through our eye, and during special nerves go to suprachiasmatic nucleus in our brain and tell us that this is day or night. And there is a melatonin, which is an endogenous hormone, which is produced especially high in the evening and not produced during the day. So there are some genetic features, and this melatonin synchronize our internal clocks and organs like heart, liver, kidney. And when we don't have enough light, so we're thinking about Arctic or people living during the night, working during the night, we have another entrainers. So it's physical activity and social time and our feeding time. So these things affect us when we don't have enough light. 2 years ago, we published a review paper about role of sleep and sleep-wake rhythm changes in the Arctic adaptations and described some features of living in the Arctic. So I present some examples on very interesting things which I found working in this field. So my colleague Mikhail Borisenko from Syktyvkar did a survey with more than 2,000 participants living in villages and cities from 59 to 67 latitude. And he showed that the most important thing affected our chronotype and sleep is time of sunrise. So during the year, we have different time of sunrise. And if we look at some cities, as example, St. Petersburg, during the December, we have time of sunrise around 10 o'clock. But we need to start our job in most organizations from 9 a.m. So we didn't have enough light during the morning time. I did some research in Khanty-Mansiysk, which is located in similar latitudes as St. Petersburg, Yakutsk, Helsinki, Quebec, Anchorage, Oslo. Yakutsk is a bit higher, yeah. And Khanty-Mansiysk has a small populations, but it's administrative center of Khanty-Mansiysk region, and there is a lot of oil. And there we also had medical staff working different schedule. So we looked at people working 24 hours, 12 hours, and 6 hours. So 6 hours is a usual daylight job. 12 hours job is when you have 36 hours off. So one day it's day job, another day it's night job. And the best choice of emergency workers is 24-hour job when you have to work 24 hours, but then you have 72 hours, so you can go to another cities, you can spend your time with children, or even have another job during this time. So we showed that the worst thing with some features is with people working 8 hours job during the winter time. So they have high sleepiness, they have a longer sleep latency, they have more dreams, And in total, questionnaire about sleep showed higher points, which is worse sleep than another kind of jobs. So during the summertime, these people also had worse parameters, but they had less sleepiness, but more frequent awakenings. We also looked at anxiety and depression in this medical staff and found only changes in these parameters among morning chronotype peoples, which prefer to work mostly in the morning and have less productivity in the evenings. So they had higher anxiety during winter time and higher depression during winter time also. So we showed that they have seasonal changes in anxiety and depression. And talking about Arctic, also similar things about history of isolation studies, because when sleep researchers started to understand our sleep and wake cycle, they did some experiments in caves in 1970s. So they tell some people to spend 1 or 2 months in the caves, so they don't had external entrainers, no daylight. So they spend some time living, doing some things. And they showed that our mean duration of endogenous rhythm is not 24 hours as our usual day. It's 24.2. So this bar shows activity is dark, and no bars, no activity is sleep. So every day people started to go sleep later, wake up later, walking longer, sleep longer. And as example, one of our participants thought that he spent 1 month, but in real situation, he spent 2 months working in this cave. So when we don't have enough light, don't have external things which synchronize us, we prefer to start our day later. What showed another experiments, my colleague from Sweden, Arne Lauden, showed that light exposure during the summertime and during the wintertime quite changes in Kiruna city, which is located almost as in Arctic. So looking at this picture, we see that light exposure during wintertime is not higher than 200 lux. But it's very important for us to have more light exposure in the morning, so more than 200 lux. Then we have some problems with sleep, especially problems with awakenings in the morning. We need to have much higher exposure, even more than 1000 lux. And these changes in daylight later and not as good. Talking about sleepiness, this experiment showed that sleepiness is higher during lunchtime. In total, many of experiments in Arctic residents during winter and summertime showed that people have not good sleep, even in summer and in winter. Residents awake later and they sleep longer during winter time. They have delayed melatonin rhythm in summer, and this evening light exposure cause circadian phase disorders. So what researchers prefer to use? So in many times they use some things like bright light. So as example, it is light treatment glasses. They use special green light, which is good, and so researchers prescribe this bright light in the morning, especially during winter time. You wake up, going your usual day, tooth your brush, take a cup of tea in the morning for 30 minutes, then take it off and start your day. So this is similar to bright light in the June. And when you don't have enough light, you need to change your physical activity, start your activity in the morning, take your breakfast early in the morning and start your social activity, so you will be involved in all these things. And during the evening, you need to reduce light at home, and especially during summertime, use blackout curtains. As example, in my flat, we have a small baby, and we need to use 2 blackout curtains to don't have enough light during the summertime. So COVID pandemic changed our life during the last year, and we had some changes which we didn't expect before. So we had lockdown in many cities and countries. We had self-isolation in Russia. We began to spend more time at home. Many of people had a remote job. As example, as a researcher, spent 4 months at home, and I went to the village and spent 2 months in the village during the summertime. So I was quite happy to have this time. And we have limitations to our outdoor activity, limited by some laws. And we had also permanent stress all this year, news about COVID-19 every day. And lockdown in Arctic cities was a bit longer than in Central and South Russia. So what showed some studies about remote job, that almost half of people started to work at home. More people working at home from UK, from US, less people working in Japan and France. And people like it. They prefer to work at home. So after things changed, only 12% of people want to return to full-time office work. 72% of people want a hybrid remote office mode. So they spend some time at office and most of time spent at home. So we can call this COVID-19 pandemic as the largest isolation study in history, and most of health consequences are related to loneliness and mental health impact. It was higher, loneliness was higher in women with less contacts with relatives. So as example, before these things happened, we had loneliness mostly in older people living without children. But now, when people don't have contacts, it's especially important for women. They develop anxiety, depression, and sleep disorders. So we have some home confinement effects of COVID pandemic, and especially reduced exposure to sunlight and reduced physical activity, changed routines, less face-to-face interactions, and poor sleep. So probably it was the reason for high anxiety and depression during the second wave. And it was called as post-traumatic stress disorder. So previously, I met many people with these problems. So freelancers, people working from home, they often have some sleep problems and changes in sleep-wake routines. So they reached the things they expected in life. So they had high salary, they can work from any point of country. They order food. They don't need to go outdoor, and they have many sleep problems because they don't need to wake up in the morning and go to job. But we also had some possible benefits of lockdown. So many adolescents follow their natural sleep-wake rhythms. They start the day later. They have a bit longer sleep durations. Many people who spend lots of time in commuting to the job, they had longer sleep duration, and we spent more time with family and young children. This is especially important for women. So in our online survey of health consequences of self-isolations, we showed that a third of people reported worse sleep quality, which is a really bad thing. Talking about these things, we looked at data from prevalence of insomnia during COVID-19 pandemic, and in many countries, this situation is worse than in Russia. So as example, in Italy, the prevalence of insomnia increased 5 times, and on average, it increased into 40 to 50% in many countries. And many people changed the sleep. So 15% began to sleep longer, 30% slept worse during this time. But also people who had COVID infection, they had some consequences. For example, in the study of Hubei from China, at 6 months follow-up, they showed that 63% had fatigue and post-COVID hypersomnia. So they had reduced productivity, and quarter of people had sleep disorders and anxiety, depression, and 40% taking sleeping drugs. So what can we do? So we had similar situation with living in the Arctic and similar isolation living the last year. So we have some rules of for the best sleep. So these rules are keep your regular schedule, especially during the weekday and weekends. So you need to have a bright morning light. If you don't have a bright morning light during the winter time, use some devices like bright light devices. You need to have home-based exercises if you can't go outdoor. You need to limit your exposure to news, and especially in the evening. And many people, they prefer to call the relatives in the evening before the sleep and call them and talk to them and discuss all these things happen during the day. And after this, they don't go to sleep. They need to discuss these things late. So many people also have bedtime procrastinations. They switch TV on, they switch the screens, see serials and news and other things, so we need to switch it off. Spend the time in the bedtime routine, and also share your worries, stressful thoughts, and social interaction with people. If you have some problems with sleep, make stimulus control. Go to bed only when you feel sleepy. If you're not sleepy, don't go to bed. And use bed only for sleep and sex, not for job. If you can't sleep in bed for 20 or 30 minutes, get up, do some monotonous things, prepare for next day, write your thoughts on paper, and return to bed when you have some sleepiness, and maintain a consistent sleep-wake cycle. So you have a maybe alarm for each morning, no matter how much sleep you get. So this is a set of rules for control of stimulus like bed. And if you have some problems with sleeping, so if you can't sleep well, you may find some relaxation techniques which can be active, like progressive muscular relaxation, or can be passive, or you can use body-mind approach like yoga, tai chi. So when you go to bed, as example, you have some audio recordings with all these techniques. You should do it and relax before to bed. So I finished my presentation, and very glad to have questions and answer them.
Thank you, Mikhail. Yes, one of the questions already been answered. It's very interesting. You were in Sergei's presentation in regards to studying the way northern people deal with challenges that the climate causes, right? And the usual climate, not even climate change. And it just reminded me about an article I read, I think it was in The Guardian, about, I think it was about a Stanford scholar who's been studying Norwegians and their specific mindset that they have in wintertime. So there was a whole study that highlighted that Norwegians, and from different cities, they approach the polar night, right, and the absence of light and the darkness differently than people in other countries. And it was in regards also to the COVID pandemic and what lessons we can learn from Norwegians. So they basically was about them taking these harsh conditions as challenges rather than difficulties. And I don't know if it's linked to a quality of life, which is probably higher in Norway than in some other countries that have the Arctic population. But do you think it's applicable in Russia, changing the mindset to, rather than facing on, like, pointing and focusing on difficulties and illnesses and stress and things like that, towards seeing positive sides of it somehow, and probably also like community support. Like, is it applicable in all countries, or maybe Norway is different?
I think it's a very good example of what to do when you have some new things and you need to adapt to these things. And of course, I think that people living in Norway, they already have prepared to these situations with COVID pandemic.
Yeah.
And yes, they have examples living in harsh conditions, and I use always some new things as a challenge. It's really interesting to find new thing, prepare. And in my opinion, it's really interesting to see how indigenous people prefer to these changes in daylight, what they do, because it's not known really. And I hope one day we will go to some places like Murmansk or Patiti, or even to Arctic, to understand what reindeers, how they living.
Mm-hmm. Yeah, we have a question as well. So how important it is it to take vitamin D in low light conditions?
Vitamin D, yes, it's recommended in Russian clinical guidelines, and all the people, even my son, from 4 weeks after birth, he need to take vitamin D, and dosage depends on latitude. Like in the European North, it should be a bit higher, and in North it should be a bit less.
Mm-hmm.
Because most of people don't have enough vitamin D, so it's a really important thing.
Yeah. Any more questions from the audience?
Question from Sergey.
Sergey, go
question.
ahead.
Yes, yes, Michael, thank you for your presentation. And the question is, could we, maybe it's not even a question, because we already have a collaborative project. We had it with children in Arctic, and we have now, is it possible to combine efforts in, what do you see, combine efforts about to make database of people who already got COVID infection, and in our regions, I mean, to have all this post-COVID outcomes like fatigue, insomnia, because I have already in my bag like several hundred of surveys, and these people already provided me DNA samples for DNA? Already they have a chronotype. Do you think what chronotype is more prone to the infection? Later chronotype, earlier chronotype? What's about your opinion about it?
Who is more prone? It's a really interesting question. I think it should be studied during this year. But in my opinion, people who spend less time in the bed, who go to bed later and wake up earlier, they have less sleep and they are more prone to infections. So it's already proved by many publications. So later chronotype is not good for this infection.
Well,
my opinion.
Well. Thank you.
Yeah.
Thank you.
So during the previous presentations, there was a question from Joel, maybe about changes in daylight in different regions.
Well, you mean about in my presentation? In my presentation, only in yours?
From Yelena presentations. Yeah, presentations when you're traveling from different cities with different daylight. So the special guidelines also recommend to use daylight devices like these glasses, or they recommend to use melatonin before travel. So there's special schedule to use melatonin as example to travel to the south, to the west or east. So you have different schedule to prepare for these travels. So to change your endogenous rhythm to the special time and be prepared to start in the morning.
And the follow-up question for that is, are the daylight glasses better than daylight lamps?
In my opinion, it's similar, but when you wake up later and you're in a hurry in the morning and try to take a cup of coffee, it's not easy to spend 30 minutes in front of daylight lamps in the morning. So it's easy to take daylight glasses and go around your flat.
It's interesting what you mentioned about the indigenous peoples being affected, right, by loss of daylight. Also brought me back to that article I mentioned, that it was stated that Norwegians in, say, Svalbard, they were more tolerant to darkness than those Norwegians in Tromsø, and those Tromsø Norwegians were more tolerant than people in Oslo. So it keeps, you know, the northern you are, the more tolerant you are to the darkness and to the conditions, because probably people who have spent their entire lives in harsh darkness in winter, they're more used to it probably, or is it genetic based? So it's interesting to see the discrepancy.
Yes, it's not yet understood these things. Maybe people have some changes in sensitivity of retina because we have light from retina, and these things not yet understood. So stimulus maybe, so they maybe don't need to have so high stimulus, not much intensity of light. And another example that there was some studies from Norway, then they had people from Russia coming to Norway to work. So they had 4 times high insomnia rates than indigenous people living in Norway. So they can't adapt to this situation.
And another question, go ahead.
Yeah.
Another question, a follow-up question too, how important is color in the environment when you deal with low light conditions?
Color of light may be important. If we're talking about different spectra of light, so we have some, as example, these daylight glasses, which is green, and we have some glasses with blue spectrum, which affects melatonin, which more affect melatonin.
Yeah,
But also,
blue, yeah.
yeah.
Which color is most like stimulating for like for staying awake as opposed to melatonin inducing? Blue, I know, is actually increases productivity.
Yes, and blue and green, but it depends on company which produce these devices. And my colleagues from Tumen, they will start special project about Arctic environment and light with the help of researchers from Switzerland, from Christian Jochen. He is a lead scientist in this field. But this project just started this year and they don't have results yet, so they didn't participate in this symposium, but I invited them because they have opportunities to travel, and they have some, in Tumen city, they have many people working in the north, in the Arctic, in oil companies. So they have, they need to commute to the job from Tumen to north cities and use these different light devices.
And is it also important for the northern settlements and cities to have like colors around? You know, people paint their houses in bright colors. We see a lot of images from Norway and Canada, so the colors are much more bright as opposed to maybe, you know, some cities and places elsewhere. So does it matter to have the colorful surroundings when you have so little light in general?
I think it's important not just because of you don't have enough daylight, but in total, you just need to have more color around. It's important for your mood. And just, I'm living in St. Petersburg, and during winter time, we sometimes have just different shades of gray, especially in the places around city where people just sleep, and you wake up in the morning and see just gray things. Not enough daylight. It's not the best for your mood. I prefer different colorful cities also.
Any more questions about any presentations today? No? Probably talked about everything that was interesting to the audience. If we have no questions, Sergey unfortunately left us too quick before I could take a screenshot of all of us, but I will still do this. So you just look at me and the camera for a little while. And 1, 2, 3. Thank you. So I think we can wrap up for today if there is no more questions from anyone. Thank you all for participating in today's third panel of our seminar, Social Development, Human Health in the Arctic. So many interesting topics have been discussed, and I really would like to know more about some of them. And I hope we can continue this discussion and talking about it further in some form. Those of our alums that are here, right, Fulbright alums, Yelena and Mikhail, you're welcome to present any of your research in one of our lectures or salons that we plan to organize further within the framework of the 75th anniversary of Fulbright globally. So we will be glad to have you. Okay, I think we can say goodbye for now. Alexei, also huge thanks for joining us and for your interesting presentation and topic. It was a great pleasure to talk with all of you, and hopefully maybe we can see you on our next panel among the attendees, which will be the last for today in 1 hour at 4 p.m. So thank you all and see you.
Thank
you.
Thank you all.